Alright, this question is taken from June 2013, question 3, part B. June 2013, question 3, part B. In the diagram below, not drawn to scale, AEC and ADB are straight lines. Angle ABC are equal to angle ADE, which is equal to 90 degrees. AC is equal to 10 meters. AB is equal to 8 meters. And DB is equal to 3.2 meters. We are required in part 1 to calculate the length of BC. Alright, now let me take out that big triangle there. Alright, so I'm looking at the larger triangle at this point in time. And the larger triangle, the vertices are A, C, and B. So A, C, B, and the length of the sides AC 10, and the length of the side AB 8, and we are required to find CB. Now this is a 90-degree triangle, so a right angle triangle, and in this triangle we are given two sides. The hypotenuse is given, so therefore we are going to use Pythagoras theorem, and we know that we have to subtract to find CB. So 10 squared subtract 8 squared is equal to CB squared. 100 minus 64 is equal to CB to be squared. So CB is equal to the square root of 100 minus 64, which is equal to 36. Square root of 36 is equal to 6. CB is equal to 6 meters. Alright, so here is 6 meters. The other part now, explain why triangles ABC and ADE are similar. Now, for similar triangles, what we have to remember is that corresponding angles are equal. Alright, so the corresponding angles are equal, and the corresponding sides, the ratio of the corresponding sides, right, so the ratio of corresponding sides are equal. Right, so that is what holds for similar triangles. Now I have the larger triangle here, ACB. Let's take out the smaller triangle of ADE. AED, right? And over here is 90, which corresponds to this angle here, and this side and this side, both sides are parallel because they form 90 degrees here and over here, so we know that they are parallel. They are perpendicular to the line AB. So if they are parallel, that means that this angle here is equal to this angle over here, so which is corresponding angles, and we have the angle A, which is common to both of them. So the triangles are similar because the corresponding angles in this case are equal, right? Again, two properties for similar triangles. the correspondents are equal and the ratio of corresponding sides are equal. The other part now, part 3, determine the length of DE. Now DE is this part here, and as I said before, that for corresponding triangles the ratio of the lengths are equal. Now the ratio of corresponding lengths are equal. If this portion here is 3.2 and this whole length here is 8, then this portion AD, which is over here, is 8 minus the 3.2, which is equal to 8 minus 3.2, 4.8. So this portion here is 4.8 meters. 4.8 meters. Now why did I find that 4.8 meters? Because I am looking at the corresponding lengths now. I have this is 6 and I want to find this. So this is my small triangle and this is my large triangle. Alright, so I'm going to set up a ratio of the corresponding sides. Large over the small in terms of the length. So that means that the large triangle AC, that length corresponds to the length AE of the smaller triangle, and the ratio here is equal to AB of the large triangle, which corresponds to AD of the small triangle, and BC of the large triangle corresponds to DE of the small triangle, right? And I just need two of these to work out what is DE. So I have this portion here, the 8 to the 4.8, so that's this here, AB to AD, which is 8 divided by 4.8. Right, I'm going to use a different color here. Right, so I'm using this and this here. Right, so this is equal to BC, which is 6, over DE, which is unknown, which we have to find out. So from this we could cross multiply and we will get 8 times DE is equal to 6 times 4.8. So DE is equal to 6 times 4.8 divided by 8, and my answer for the length of DE is equal to 6 times 4.8 equal, divide my answer by 8, I get a length of 3.6. So the length DE is equal to 3.6 meters.